Hello everyone, let's look at unique path. The problem statement is, there's a robot located at the top left corner of an m multiplied n grid. The robot can only move either down or right at any point in time. The robot is trying to reach the bottom right corner of the grid. The question is, how many possible unique paths we can find? Let us look at example 1. The input m is 3, n equals 7. So, that's 3 rows, 7 columns. The output is 28. This is a typical dynamic programming question. The problem is actually we are at index 00, that's top left, and we want to move to index m-1, n-1, that's bottom right. Let's have a look how we can solve it. In the beginning, the robot is at 00. What if we want to go to 01? That's here. How many paths we can have? I think it's 1. The robot only needs to move right. How about 02? That's this place. I think it's also 1. How about the rest of this row? It's all 1. Let's look at vertically. For this position, 01. How many paths? It's also 1. How about this? 20. It's also 1. It just keeps going down. So, we can say for this row and this column, there's only 1 path. How about in the middle? That's 1, 1. I guess it's 2. The robot can go right, go down, and go down, go right. So, to go to this position, it has 2 paths. How about go to this position? That's 1, 2. To get to 1, 2, you either at 1, 1 or 0, 2. To get to 1, 1, you have 2 paths, and then you can go to 1, 2. To get to 0, 2, you get 1 path, and then you can go to 1, 2. So as a result, go to 1, 2. You have 3 paths. That's adding 2 and 1. That's adding this value and this value. So for the rest of all the position, we can do the same thing. And then, in the end, all the points will have a value. That's the value is adding its left value and its top value. In the end, we can get finished. Let's look at the implementation. We will need a 2-dimensional array. Its size is m multiplied n. Its value will be all possible unique paths we can get there. And for the first row and first column, the path number will be 1. Because it's 2-dimensional array, so we need to have an array inside the array. Let's give all initial value to be 1. By doing this, we have our initial memo array. All the value will be 1. And then we can have our for loop. We have these 2 layers of loop. And all the start index is 1. This is because the first row and the first column already have initial value. And then we can get the individual value by adding its left and its top. And in the end, we need to return m-1, n-1. Let's submit. It looks good. To solve this problem, we just loop through the input array, and we generate the next value based on its previous value, that's adding its top and its left. If I did not make this clear, feel free to go back and look at the explanation for this example again. Let's look at the complexity. For space, it's obviously O of m multiply n. That's the size of our memo. For time, it's also m minus n. This is because we have this loop for the row and loop for column. Thank you for watching. If you have any question, please leave a comment below.